Okay, so yeah, I'm Richard Hollard from Proclima, just like it says on the name badge. I've got a poor short-term memory, so I thought I'd wear a name badge. So I'm going to be talking to you tonight. I haven't actually been given instructions on how to use this. Oh, yeah, there we go. About the importance of air tightness and ventilation for a healthy home and how they work together. And like Brandon, I love analogies, so I thought I'd use one, and I'm glad I didn't do the human body one now, because that's already been done tonight. And there's also been a lot of talk tonight already about ventilation and air tightness, so it's going to be repeating a lot of stuff, but hopefully adding something new as well. So my analogy is we look at this lovely roast meal, and apologies to all the vegans and vegetarians out there. But you look at that, and that's comfort food, that's great. How are we going to attack this meal when you're probably all getting a little bit hungry right now? Add a bit of gravy on there and a few peas, and that's an ideal meal for me. So firstly, we're going to go, okay, how are we going to attack this? We're going to grab a fork. So if eating this meal with a fork, you'd be able to pick up the veggies, have a bit of a go at cutting the meat with your fork, but hey, it's going to be a little bit awkward, but a little bit difficult, and you might have to pick the big bit of meat up in one go. But so what about if we just use a knife? We can cut the meat up nicely. We can stab at the veggies and have a good go at it, but it's still not going to be that easy. So what do? You'll know that, I don't have to tell you that. A knife and fork is a great system. They work together, they complement each other, and then we have lots of happy people. So lessons we can learn from this little analogy. Firstly, it's possible to use just one utensil in this analogy to eat the meal, but it always works better with two. They work as a system, they complement each other. The experience is much better. So they work as a system. It's simple, effective, and a proven system. So did a bit of research actually. I think the ancient Greeks introduced knives and forks, so they've been around quite a while, and they'll probably be around for quite a while after today, unless we all start eating sort of protein pills or something. But who doesn't love a good roast meal? So they have a mutually beneficial relationship. The fork helps the knife do its thing. When you're cutting meat, it's good to use a fork to hold it, and the knife helps the fork as well. So you're not chasing food around the plate. So, and you're probably wondering by now, is this guy at the right event? Does he think he's at the food show, not a housing event? So what am I doing here? And the analogy is the knife and fork are a little bit like the relationship between air tightness and ventilation. It's a mutually beneficial relationship, and they complement each other. They don't work against each other. You could probably get by with just one of those two things, but it always works better with both, as Bob and others have said so well already tonight. So firstly, if we're going to look at a couple of examples, if we ventilate a building, but it hasn't got an airtight building envelope, and for those of you not in the industry and used to all these fancy jargon words, building envelope is what we're talking about, is the floor, the walls, the ceiling, the outside, the thermal envelope of the building, where the insulation lies. If we did that, we ventilated, but we didn't have air tightness, we have no guarantee of where air is coming from and going to. Basically, it's like trying to ventilate a sieve, or hold anything in a sieve that's not big. So it's a little bit like that. We've got an air leaky envelope, and that's pretty typical of a lot of, especially older houses in New Zealand, villas and that sort of thing, which are just so air leaky it's impossible to ventilate or heat or do anything properly because there's so much loss. It's going out quicker than it's coming in almost. So which is why we often just heat one room, the lounge or the kitchen, and we run to the bedroom and hop into bed before we get too cold in the hallway. So on the other hand, if we have an airtight building without adequate ventilation, we're potentially trapping moisture. We're creating more humid conditions. So we get quite a bit of that. And this is commonly what we see in a lot of code-built houses these days. The houses are naturally getting more airtight as time goes on because of just the materials that we're using. The windows seal a bit better, jib linings and all that sort of stuff, insulation, coatings. Houses are more airtight almost by accident than they were years ago, but we almost didn't mean to do that. but we haven't actually increased the ventilation code, haven't changed the ventilation code for years. We're still relying on openable windows for ventilation. But if we don't have the right conditions, a breeze blowing through from one side, you often see those summer days when it's really still air. You can have all the windows in the world open, but there's no air movement. We're not actually doing anything. We're probably actually bringing in warm air, if anything. So if we have an airtight building and we don't ventilate, then we get a lot of that. So the ideal is an airtight building with mechanical ventilation, as we've already heard tonight. So we have ultimate control over internal humidity and temperature. So we've got outside, we've got obviously the temperature. It's quite cold out there now. I just stepped outside for a phone call, and it's amazing how quickly the temperature can drop in half an hour even. We've got a fluctuating temperature and humidity outside. We're ideally wanting to be 18 to 23 degrees roughly, and 40 to 60% humidity inside. So we want it nice and even inside, no matter what the outside is doing. So we want something like that. And it actually looks like a cross-section of Joe's house. Cut through of Joe's house. Nice, simple form. The black line, the solid black lines representing the weather tightness, the insulation, the structure, and the air tightness layers all in one. It's all there. They're all continuous. If we have breaks in that envelope, that's where we have air leakage and we have uncontrolled. Oh, go back. So you've got your man there sitting there in the nice comfy chair. He's got a very small heat source. He's got the heat recovery ventilation going, and he looks pretty content, a bit more content than the guy shivering in an air leaky house. So as far as ventilation, I've talked about mechanical ventilation. Just go through the types because there's a lot of misconceptions, a lot of terminology out there in the industry, and there's one brand in particular that's got an acronym that sort of makes everyone think it's something else. So we look at positive pressure ventilation. I've got one in my house. It wasn't there. It was there when I bought the place, and it's probably the sort of ventilation system that you might have if you've purchased one from a locally made local company in the last 10 or 15 years. So you're basically pumping air in from the roof space, and so if something goes in, it's got to come out. I was on site this morning doing helping out with the blower door test, which is an air leakage tool, identification tool. And basically, if you suck air out of a building, it comes back in the form of a draft, because otherwise it would basically implode. Like a Coke bottle, if you suck air out of it, it doesn't come back in because there's no internal ventilation. So in this positive pressure systems, air is pushed in, it's got to go out, and it goes out through any gap or crack in the envelope. Could be an open window, but it could be a light switch or a power point. And so if air's going out, moisture's going out as well, humidity. And we don't want humidity going out through gaps and cracks in our walls because that's where mold starts growing. So if we're pushing air out, pushing heat out as well, so there's no heat recovery in that scenario. On the other side, and this is quite popular, I think, in the States in some areas, a negative pressure ventilation system, mechanical ventilation system. It's like a bathroom fan running on low all the time, just constantly extracting. So replacement air, the air that's got to come in to replace what's been taken out, comes back in through those gaps or cracks or windows in the envelope. And so we're constantly basically sucking heat out, so you might be heating in one room, extracting in the other, and it's just going out the window. So not that efficient. So a balanced heat recovery ventilation system is the best of both worlds. You've got your extraction of moisture, you've got fresh air coming in, but you're not losing the heat from the air that's going out. You're recovering it or using that heat through a heat exchanger. So extraction of moisture, new air coming in, and if you've heated to a certain level, you're basically utilising most of that. You're not losing it out the window or out the walls or the ceiling or the floor. So air tightness, this is what it can look like. This is our product Intello. It's an airtight membrane and a humidity variable vapor control product that's in a house in a ceiling. Combined with mechanical ventilation that's in the same job, that's some ducting running through and in front of the air tightness layer, so inside the thermal envelope where the ventilation system should be, so that the ducting is actually warm, it's not cold and condensating. So those two things together give you Comfort, that's all we want in the house. You know, we want to be comfortable. Actually, it's the most comfortable picture I've ever seen, to be honest. It just makes you feel happy. Comfort is all about that temperature and humidity control, the 40 to 60% humidity and the 18 to 23 degrees Celsius. It's not about comfy couches, really. You could have the comfiest couch in the world, but if it's cold or humid, it's not going to be that comfortable. Health, it's all about healthy homes tonight, obviously. So normally if you're comfortable all the time, you're going to be more likely to be healthy. And that's about the air quality. If we're not pulling in air with our ventilation through the wall, we're not pulling in insulation particles and mold spores and things like that. If we're actually breathing healthy filtered air, fresh air, then we're going to be much healthier, better outcomes, less respiratory conditions. Energy efficiency, we can do all this, it's great, but we can do it in an efficient way that's even better for our pocket. You know, you can have great goals, save the world, all that sort of thing, but at the end of the day, people just want to be not spending more than they're earning, basically. So energy efficiency, if we can have a healthy home that is energy efficient as well, without costing us the earth, that's even better. And durability. If we're keeping moisture out of our thermal envelope, controlling where it goes, out of ventilation system, or out a window, not through the wall, and we're lowering that humidity levels, then the building's got to be much more durable. So build tight, ventilate right for healthy, comfortable homes. Living, sorry. Whoops. That's it.